Good morning, everybody. I'm thinking I'm just not going to turn my camera on. No camera, no microphone. Just going to be.
Extra credit. Why not still?
That's right. I think that was probably Solomon.
Yes, sir.
And
Good morning.
that was me banging on my desk. Let me see the chat. Oh, thank you, Mike. Oh. Goodness gracious. Jonathan, what is the significance of burn Babylon down? That's all right. I think he's orbiting a black hole and he's not aging. So my voice is coming into him like super fast, like you can't understand it. And to me, he looks completely stationary. Okay, hold on. I'm going to start my video. Now I'm going to go ahead and just surrender to the nose cam. I hate it, but I've got to do it. Because I want to use the document camera today. Good morning, Casey. And Cindy, how are you? That's what David Letterman used to do. And also it lets you know how well or how poorly synchronized the audio is. Does it seem synchronized? The paper and the sound? Yeah?
It's pretty synced. There's no lag.
What?
There's no lag from the paper clapping to the sound audio.
Excellent. Excellent.
Sleep.
All those little packets of data, they probably have some sort of timestamp, you know? And so when they get to the computer, they know they're supposed to play at the same time. I think that's how that works. But you know, every pixel and every little sound compression piece of information, it's digitized and sent over this enormous network, of course, right? And that means that every piece can go a different way in getting to your computer. And then every piece on your computer can go a different way getting back to me. Yeah, it's kind of amazing. Good morning, Ben. How are you?
Hi.
Hi. You have the jellyfish.
Oh, yes.
Jellyfish. That is so cool. Okay, I have to get some kind of background. All right. So thank you, Nicholas, for your request that I do problem 7. This falls under the category of you assigned it, man. You better be able to do it, which is absolutely true. However, okay, come on. You have to work now. Oh, I got to plug it in. Plug this stupid thing. There we go. Oh my God, it works pretty well. Huh. Goodness gracious. Okay. Let's see. We'll share. Document. Okay. So, problem 7 is like, you know, it's not impossible by any stretch, but it was a problem for me. So this is question 7 of the homework. And in question 7, they give you all kinds of information, but they leave a gnarly little problem right up front. And that gnarly little problem is about determining the pH of a mixture of weak acids. Right? And so let me put out the premise. I'll put out all the data, right? Yeah. 29 mils of a base at 0.07 and 8 molar. That can vary, right? Base, and the pKa of that conjugate acid of that base is 4.5. And then you take that and you add it to 29 mils of 0.05, 25 molar acid, weak acid, HA. pKa of HA is 3.273. And then you add 1 mil of it's a 0.123 times 10 to the minus 3 molar indicator. We can call the indicator HIN, right? And then we dilute everything to 100 mils. Right? So we make a couple measurements. We make an absorbance measurement at 550 nanometers, and we get 0.1187. And then we also know that the extinction coefficient at 550 for HIN, the acid form of the indicator, is 2.26 times 10 to the 4, and epsilon at 550 for IN minus is 1.53 times 10 to the 4. HIN and IN minus, right? So this is the entire premise. And then the first question that is asked is a little bit odd here, right? But the first question is, what is the pH? And to my astonishment, when I first looked at this, I just didn't know how to approach it. I was like, what? What is that? And you know, I approached it a number of ways, and I kind of failed. I guess I failed up, you know, because I got a little bit better at it each time. But let's kind of flesh out the information that we have, and you'll see how it's not quite as bad. There is a trick, however. It's not really a trick, but it's a trick. Okay. So let me actually get a new piece of paper here. This makes sense. So the first one is the first information we're given is that HB plus, right? That is the protonated form of the base, right? And if we write it as an acid in reverse, right, we get that goes to H plus B neutral. The pK is 4.559. And the K value there is 10 to the minus 4.559, right? So this is 10 to the minus pK. And that's going to be 2.67. Oh, I'm sorry, 2.76 times 10 to the minus 5. We get HA. That forms H plus plus A minus. Its pK is 3.273. Its Ka then is 5.33 times 10 to the minus 4. So what we're mixing together is HA and B, right? Sort of equal components of these. More than sort of actually equal. Well, not exactly equal. There's slightly different concentrations, right? But we're going to have to write this guy in reverse, right? So we're going to have to write B plus H plus makes HB plus, right? And then the K for this one, this is BKB, right? Will equal 1 over it's Ka, right? And that will equal 3.62 times 10 to the plus 4. Actually, 3.622, 2.761. I should add a digit here because these three sig figs come from, oh wait, I've added an additional sig fig. This is 4 sig figs. This is actually 3 sig figs, but that's fine. I'll just add it. We'll add one additional sig fig. Okay, so we can call this guy 1, this guy 2, and this guy minus 1. Okay, so the overall reaction that we're dealing with is minus 1 plus 2, and that is HA plus B makes HB plus plus A minus, right? And the K here is equal to K minus 1 times K1, right? It would be this K times this K. Oops. And this K here comes out to 19.32. So here we have our operative reaction. And what we're basically asking is, what is the pH? And what I didn't see at first is that, and honestly, I still don't completely see this. I don't get it soup to nuts. But the pH of this system is still equal to pKa plus log of A minus over HA. You know, and it's also equal to the, and this is pKa 1, or pKa minus 1, right? So pKa 2, rather. It's also pKa 1, right? Plus the log of, let me get this there. HB plus. Does that make sense? I know it's kind of boring, but and I think Casey already has the answer to this. I cheated in a different way, but I didn't cheat out Casey's answer. It makes sense, Cindy? So far? I don't know if you're a math person or not. This is very mathy.
Yeah, I'm going through the homework and it's pretty rough.
Yeah, I think it's rough. I think it is. It's pretty rough, right? So I'm, basically I'm giving away the answer here.
But I appreciate it. So are these going to be on the exam, Dr. Terrell?
What?
Are these type of questions going to be on the exam next Thursday?
Yeah, I'm only going to pick the hardest questions from the homework, the ones that take probably 3 or 4 hours a piece. And I'll give you like 10 of them. Right, man?
Sounds about right. Okay, thank you.
No, I'm just kidding. Of course, I can't give you anything even close to this difficulty. I mean, if anybody had given me, if anybody gave me this as an undergraduate, I wouldn't even know what hit me. I would just be like, what? What was that question? And it would just like go right over my head, I would not even know.
I feel you on that one.
So, no, actually I have to ask really easy questions.
Okay.
And, so what I'm going to do is I'll go through the homework and I'll go through, and I will make very homologous questions, maybe some simple calculations, and I'll pick out some equations. It's like one equation per problem, right? Where everything's laid out clearly, not hidden in a bunch of other stuff, right? I mean, in a way, ultimately, you have to face that, right? You have to face that problems come hidden in other shit, you know. But I promise to give you very little extraneous information, so I can just see how you can get through these sort of focused problems, right? So,
Okay.
Anyway, so moving on, right? So this point here, that the pH of this system, right? There's no free H plus in this system, right? But when we're done, these things will still be true. And we're going to know A minus and HA and B and HB plus. And therefore, and we're going to know pH, and we know the pKs, right? And so we should know the pH, right? And if I get this wrong, forgive me, because it's still a little bit mysterious to me how to equal both of these. But we'll just proceed accordingly. That I'm pretty much 99% certain that this is how this is done. Okay. Now there's a little trick in it, right? So first we have to compute B and HA, right? Because this K value here, we'll call this K RXN, K reactor, right? Because K RXN will equal the product concentrations over the reactant concentration. So that's equal HB plus into A minus over HA times B. And so we got to know as many of these as possible, right? So let's calculate BF and HAF, like the formal concentrations of these. Concentrations before they change due to dissociation or association, right? So this is equal to 0.0788. I think that was, yeah, this was part of our setup, right? Molar, right? Times, okay, we can actually substitute the molarity with the moles, right? So let's do just the moles. And we can do 0.029 liters. This is actually moles per liter, right? So this will equal 0.0022 85 moles. This guy similarly will be 0.02 times 0.0, oops, 0.05 times 0.29 will equal 0.001522 moles, right? And then what we're going to do is we'll set up a reaction scheme for these guys, right? Which is we have HA plus B is to A minus plus HB plus, right? And we've got initially, then we've got 2.28 and 1.52 and 0 and 0. These are the initial conditions. Then a certain amount will react, right? And this is going to go 2.28 minus X, 1.52 minus X, and X and X. That's how much will form of these two species, right? And we're ignoring H plus and OH minus right here. Now, this breaks down to, here's the equilibrium case, right? Products of the reactants is going to be K Rxn will equal x squared over 2.28 minus x times 1.52 minus x. And so this will equal 19.32. So, and these are millimoles, right? And so x will be the extent of the reaction in millimoles. Right? So let's see what that works out to be. I need more paper. So, oh wait, no, there's paper right under there. Shoot. So, x squared over 2.28 minus x times 1.52 minus x is equal to 19.32. And so we can, let's solve for x, or let's set this up as a quadratic, right? So we've got we're going to cross multiply. So we've got x squared well, actually, let's not do any of that, right? Let's just leave it like this, right? I mean, this works out to be a quadratic, right? I think it's quadratic equation, right? But let's just approach this in a different way. Let's approach this computationally. And I'm going to grab my cheat sheet here for our homework, or my Excel sheet for our homework. And I will show you how I did this. If this cares to open anytime soon. Okay. Go. Change my share. Share. So okay. So let me mess this up. Okay. So right now, what we have is x squared over this, right? This is our equilibrium expression here, equals 19.319. That's the K, right? So let me actually, let's see. So, right? And that is equal to, and this is just a number, right? 19.3, right? And so what I'm doing is I'm guessing that x here is equal to 0.001. And if x is 0.001, then this quotient comes out to 1.46 minus 6, right? And that's not equal to, this should be like question mark, is it equal to 19, right? So there's no actual connection between these numbers, right? And what I'm going to, and according to this, the pH here, Ka plus this log term equals pH, right? So this is the Henderson-Hasselbalch equation. Right? So, and this is also not equal, right? Well, I don't know. Actually, it's not really a question so much of equal, but we're computing the pH, right? Assuming this extended reaction of 1 millimole, right? And so let's what we can do here is we can try different values of x. That's getting better, right? You know, it's getting better slowly, obviously, you know. Yeah, getting better, right? Basically, this is becoming more equal to this, right? I put in a 1 there. Now we're taking it. 1 millimole, it's looking better. 2. Whoa, 2 is too much, right? The 1 is getting better there, you know. So let's just leave it 1 and let's let the solver do this groping thing, right? I'm going to use again data up here and select solver. So those heroic few of you who are way better students than I ever was will catch what I just did. Right? I set up this equation right here, and then I put in the variable x here. Right? And now I'm going to use solver, and I'm going to set the objective cell to be right here. And I'm going to set that objective cell to be 19.319. That's the K value. Okay? And we're going to change this cell such that this equals this. Right? We're going to change this cell until this equals this. And then it will be solved. Does that make sense? Shake your head, yes. Just pretend. We're going to change this cell, which is x, right? Until this expression is equal to 19, right? And this equation will be solved, right? And we're just going to do it by groping. Is it this? Is it this? Is it this? Is it this? We'll try it a billion times, and no time will elapse. You know, no time will elapse on the surface of the black hole. Right? So I'll just try it. We'll just try it. Right? By changing B3, right? we're going to make E5 equal to this. So let's solve this. And I'm going to keep the solution, right? And A minus here, this term is equal to 1.437, right? And when this is equal to 1.437, then that squared over to that is equal to 19.319. And we are solved, right? That means that HA, which is this, will equal this, 0.08, right? And then A minus. And then this is A minus. This is A minus and equal to H plus, right? We'll equal that, right? And then this will solve for our pH in the Henderson-Preston equation. Not a whole lot of conversation here, but it's really important to sort of get through this cognitively. Because this is how you solve things numerically. And it's very deceptively simple. This is a one variable solution, right? There's just some value of x for which x squared over this is equal to that. Okay? So what we do is we try a value of x, we compute it, and we say, is it equal to that? We try a new value of x, we compute it, we say, is it closer to that or further from that? If it's closer, then we go the same direction. If it's further, then we go the other direction, right? And we're assuming that there's some sort of function where there's a minimum when our value of x makes this expression equal to that. So now in this case, I will go back to this guy again. We can turn on the light there, right? And x equals, hold on. Uh, 1.437. Right? So 1.437, we can subtract it from both of these terms, right? So now the next thing is to compute the pH of this, right? So this is the extent that HA plus B gives A minus plus pH plus. And so this guy will equal 2.28 minus 1.4378, right? This guy will equal 1.52 minus 1.4378. And this will go to 1.4378 and 1.4378. Now, the trick here is to recognize that at any point here, the pH must equal the Henderson-Hasselbalch approximation here, which is pKa plus log of A minus over HA, for example. So, let's see. So the pH of the solution was given, right? And that's actually an easily measured thing. Oh, no, the pH is what we calculated, right? And so the pK was given, and the pK, the first one is 3.273, plus the log of A minus over HA, which is 1.4378 over 2.28 minus 1.4378. And this should equal, if I'm not too messed up here, 4.503. Is the pH. And this is where the whole thing kind of cracks open, right? We got through this problem where we have a reaction and two K values. We computed an overall reaction K. Then we set it up such that we could solve for the extent of that reaction by solving this quadratic equation. We solved this in solver, right? And then we substituted the values that we got back into the Henderson equation. Now this is where I'm not 200% solid, but I think this works. So, let's see what we get here. Um, So the next thing to do is to determine the pKa of the indicator, right? What is the pKa of HIN, the indicator, right? And so let's just sort of go through and calculate it out, right? So in the preparation of the indicator solution, we had 1 milliliter of 0.000124 molar HIN, and we QS that to 100 mils. The absorbance at 550 at that point is equal to 0.1187. Right? But we also know that the extinction value for HIN at 550 is equal to 2.26 times 10 to the 4th, and epsilon at 550 for IN minus is 1.53 times 10 to the 4th. Not so different from crystal violet, right? So there's a variety of ways to approach this. But what I like to, what I was inspired to do here is compute the stream of absorbences, right? If it was all HIN and all IN minus, right? And then figure out where we are on the scale, right? And then use this value and this value in a Henderson-Hasselbalch type equation to get the pKa. Right? And this is the A of the mixture. Right? So to get the absorbance of of either of these extremes, right? We take the original concentration, we do the dilution calculation, gives us 1.4 times 10 to the 6 molar, and we take A of HIM is equal to epsilon times E times C. Okay. A little twist in here, B is 5 centimeters, right? So epsilon here is 3.26 times 10 to the 4 times 10 to the 4. B is 5, and C is 1.24 times 10 to the minus 6. This is molar, centimeter, and molar per molar per centimeter, right? So this comes out unitless, which is suitable for absorbance, right? And this guy here works out to be 0.14. Oh, so 0.140, right? A of IN minus here is equal to epsilon BC, and this is HIN minus, right? And at its extreme, if the whole thing were IN minus, this would equal 1.53 times 10 to 4 times the same two guys there, 4, 1.24, and this guy comes out to be 0.09. So 0.09, let's say. So, okay, so absorbance of the actual system is equal to 0.1187, right? So now we're going to say that pH is equal to pKa plus the log of the A minus form over the HA form, right? Which is pKa HIN plus the log of the IN minus over HIN, right? This is what we're looking for, right? This we have from the prior, and this we have from what we're doing right here, I think, right? So Now we have to figure out which of these, oops, sorry. What we'd like to do is we'd like to figure out which of these values, like here, is proportional to the IM minus, and which of these values here is proportional to HIM, right? So I'm going to posit here that this value here is proportional to the concentration of HIM, and this value here is proportional to, and it's all IM minus, and this would be, no, so this is proportional to HIM, and this guy is proportional to IM minus. Does that make sense? Yeah. So when this goes to 0, then it's all HIM, right? And IM minus is 0. So, yeah. So the IM minus fraction of this guy is equal to HIM minus HIM minus A mix. Okay? So let me get that down here. And then I'll move forward. Okay. So what I'm trying to do is I'm trying to set up an equation that works for us here. And what I'm going to do is the pH that we got earlier was 4.45 is equal to pKa plus log of 0.14140 minus 0.1187 over 0.1187 minus 0.0948. Yeah. Oh, okay, got it right. And so this guy here, the pKa, when you solve for the pKa here, is equal to 4.457. Oh, great. And I think that's all there is for this problem. And that only took an hour. Jake.
Oh,
That's all we had to do.
I know I'm super slow. Yes, Cindy?
Is that all we had to do?
That's right. That's right. Just 10 problems like this on a 20-minute, on a 50-minute exam. No, just kidding. I have to give you qualitative life questions for the exam. So, what I was thinking of doing was going over the Raman stuff with y'all in the remaining time, if you'd like, or I could, if there's any other requests, I could do them as well.
Can you go over the Raman, please?
Can we
Dustin?
go over 10 and Raman?
So I've got Raman, and then
Question
Raman
10.
and I don't
Question 10.
have question 10 ready to go. Let me see. Oh, the microopathic. We can do that. I've actually already done that one. So I'll defer on that one if that's okay, and I can do it during outside today. If that's all right. But let me do Raman to it. And I'll do it like I'll go to the oh, let me get a share. Yeah. Can you guys see the canvas thing? Oh yeah, and actually that's a good question. So, no, there's no labs next week. Because there's a couple of things going on. One, I'm getting vaccinated my second shot next week, so I might be a little out of it on Thursday. And then, first of all, it overlaps with my lab on Wednesday. So, we can take another week towards the end of the semester. We'll just take this week off, and then anyway, so no labs next week, and then yes, and I'll put out an announcement to that effect too, so that folks know. But can you guys see the canvas? Okay, excellent. So what we're going to do is we're going to go to Files. Oh no, I'm not logged in. Come on. I gotta log in again. How weird, it's just logged in. Okay, so I'm going to go to Files. And then I'm going to go to Lab. I go to Raman data. And I will steal one mistake here, right? And what I'll do is one by one I'll download these guys. I'll put them on my desktop. Desktop. Couple acetate. And unknown. And I'm going to open Excel. And I'll just open a new tab here. And I'll call this guy Raman. I'm going to go to File. I guess I'll just try open. And then I'll go to the desktop. Oh man, I hate how screwed up. How screwed up this is. You know? Easy login. Desktop. Yeah, I gotta make it equal. I gotta make it see the txt files. So I space that txt. Right, that's important. Open. Oops. Which desktop is wrong? I got. Oh, nothing. can't you, right? Oh my God. Come on. Can't find anything. It's never happened. Why? Okay, let's see. Maybe I should go. All right, maybe we should. Okay. Maybe I should. Right? So I'm going to try dragging these onto. That did not work. But it found it, right? So this is desktop, right? Hmm. So this thing over here, oh gosh. No, I gotta take a 5-minute break, guys. I'll be right back. Oh gosh. Thanks everybody. I think I'm just gonna try re-downloading these things. So I'm gonna go download them, but I'm gonna download them to some place. Okay.
Dr. T, I have a question.
Yes.
I can't find our crystal violet data.
Oh yeah. So you're welcome to steal.
To steal?
Yes. Yes.
Okay.
Use
We
anything.
lose our data.
I know, so full disclosure here, I'm not going to grade you on accuracy. I mean, I would really like to. I would really like to get an accuracy thing so you know your data trail and you can get your absolute extinction coefficient. But if you just tell me, hey, I had to steal the data here, then that's fine. I'll try to find it again, but I think I've scoured that drive, as far as I know, I don't know where your data is. So next time you come in, you're welcome to record or whatever, but also feel free to steal.
Is it the same with Raman then?
Yeah.
Okay.
Ramen is even easier.
Okay.
Just don't mix and match with the ramen.
Okay, got it.
Okay.
Thank you.
Let's try importing from the text file here. And I'm going to go to, let's see. I'm going to go back to this. We go to, oh God, this is horrible. Takes you down a rabbit hole here. Users, Roger, Google Drive, G Drive, H2, come on, let's see here, add, 855, 2021, and then, where's the, oh, there they are, that's, oh geez, import. There we go. And let's see what it is. That's it. There we go. Perfect. Now we can go to um, what time are you at? Probably insert, data, the data, and file, and text, acetate, import.
Dr. Terrell?
Yeah.
Oh, I was just wondering, do we need to install Lockdown Browser for the exam next week?
Yeah.
Okay, thank
I
you.
am so sorry, but we have to sort of do that. Okay, let's see.
Dr. T,
Yes.
would there be a space on for us on Canvas where we can submit our work, or is multiple choice?
question? I'm so sorry. I'm not quite sure I understood.
So for the calculation wise, do we input it, write it down directly on Lockdown browser, or is there a space for us assignments where we can upload our work on Canvas?
Oh, I got it. Can I answer that on Tuesday?
Okay.
Not exactly sure what format I'm going to use for the exam yet. I'm not completely final on that, you know. So okay. So what I'm going to do here is I'm going to go to Apple Acetate. I'm going to grab column 2, copy it into a new sheet. I'm going to get acetone. Copy it into the same sheet. This is EA, right? Oops. Lost the copy here. This is acetone. Okay, so it's 8:45. So if you need to go, please feel free. And what I'm going to do is I'm just going to continue to go through this, and I'll record it, and I'll make a special one on this. It's already out there, but I kind of wanted to go through this for those of you who want to watch real quick.
Professor?
So let's see.
Professor?
Yes.
I have a question about the exam.
Yeah.
What's going to be given on the exam? Are we going to be given variables, equations? What's going to be given?
No, you have to memorize everything. Okay. If you ask a question, that was unfair of you. Let's see here. No, I think I'm going to try not to make you memorize equations, but I tell you what, I will. I'll give you a cheat sheet with more information than you need. Okay.
Okay, sounds good.
And you have to figure out whether it's relevant for the average length of an elephant trunk is. To your Chem 155 experience. All right. So first thing we want to plot it out, right? But in the interest of time, I'm not going to do that here. Which is really where all the interest is. Oh, well. Let's just get the numerical answer right away. Here we go. 1, 2, 3, 4, 5, 2, 3. So we'll go 2, 3, 4, 5, 2, 3. So 5 by 3. We highlight this block of cells. We come up into the formula bar. We've got equals in S. Open up the red. And the Y values will be the intensity for F-lactate, acetone, and toluene, respectively. So I'm going to go 3 over 9, I'm going to go shift control arrow down and type a comma. And I'll just drag this stupid thing up. And I'll click here, I'll go shift control arrow down again. And I'll type another constant another comma, and constant I'm going to set to false. And the last one is stats, so I'm going to set stats to true. I'm going to close the parens, and I'll just come up with a top here so you can see what happens. And I'm going to type Shift, Control, and Enter. And it's all, wow, what is going on here? Oh, I think I got these backwards, don't I? Yeah, I got these backwards. Oops. Sorry. I got the Y's and the X's backwards. The Y's are here. And the X's are here. Oops. The Y's are here. And the X's are here. And then, oh, come on. I hate you. There we go. And then I'm going to type a comma. And then they start deleting. And we got false and true. And this will work. We said Shift, Control, Enter. What's wrong there?
Shouldn't the y-axis be the wave numbers?
No. Wave numbers have nothing to do with it.
Okay.
The y values are correct. The x values are correct. False for constant, true for static. Oh wow. Jesus. I don't know what's going on here, guys. I think it may have to do with how I imported the data. Something weird. So I'm going to give up, officially give up, and apologize for wasting your time for the last 15 minutes. I will pay in eternal damnation. But I promise to get back to you on this very soon. Okay? So, hate it, but I gotta give up. Gonna go to lab now. I'm gonna feel better soon. And thank you, everybody. Yes, and I will post the existing videos, however embarrassing they are to me. I will post them. Okay, guys. Sorry, I've got it. Bye.